Hotline, what is your emergency?
Welcome to the special Halloween edition of Homework Hotline. I'm Rebuka, a math teacher at Emily Griffith High School.
Well, that's spooky. I'm also a math teacher at Emily Griffith High School. My name is Nocturnal Nathan.
Are you stuck on a math problem? Well, that's why we're here. We'll help you work through the problem so that you can better understand it. Also, when you get all that candy, you can count it properly.
We're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. Give us a call at 720-424-1666. Calling us in allows us to help help you a little bit more thoroughly.
You can watch our show in several different ways. You can tune into Comcast Channel 22, go to livestream.com and search for EG Homework Hotline, or watch us on YouTube by searching for DPS TV Homework Hotline.
So far, we've pretty much just been answering your math questions, but next week we're going to have a science teacher here to help you with those questions.
So are you confused with chemistry, spacey on astronomy, divided on which phase of mitosis is the most important? Well, starting next week, you can ask Sam. So Sam, why don't you come over to the set?
Hey guys, how's it going?
Hi, Sam.
Hi.
Nice costumes.
Thank you.
Thanks.
Thank
I
you.
like yours too.
You know,
Cool.
actually, this is just how I go into work every day.
Oh,
Oh,
oops.
that's
Sorry.
convenient then. It kind of just worked out.
Sorry.
Yeah, it did.
It does, works right
Yeah.
out.
Oh yeah, definitely.
So tell us a little bit about yourself.
So I'm a science teacher
Okay.
at CLA, not at Emily Griffith. Obviously, you guys
That's
didn't know that, I
okay,
guess.
we
Yeah.
forgive you.
Yeah, I appreciate that. I do. I teach chemistry. At least this year, I'm teaching chemistry. My background is in geology, but
Okay.
also in Spanish. I have sort of a weird
Oh,
journey
okay.
that made me a science teacher.
There are
Oh.
rocks in
I
Spain
was
too.
Well, that is true. That is true. There's lots of rocks in Spain. I was a Spanish teacher, and then I
Oh.
decided that I wanted to use my Spanish in another way. I've been
Okay.
a park ranger for about 2 years.
Oh,
And
Wow.
so I worked in a park that had a cave in it, and I sort of specialized in cave geology.
That's
And I
pretty
used
cool.
that knowledge and that experience to go into being a science teacher. And I ended up at
Gotcha.
CLA after I got my science teaching license.
awesome.
Yeah.
Very nice. So all your science and Spanish homework questions.
Oh yeah, if you have
So-
Spanish homework questions, you can call those in. I'll
So we
change
can
into
even
like
do
a
that.
different outfit.
Yeah,
Maybe
very
with a sombrero.
versatile, yeah.
I'll
Go
do
back and
Spanish
forth.
questions.
That's awesome. Well, so Sam is going to join us, and we're really excited to have him. So science questions can all be answered. So thanks for joining us today, Sam. and
Thanks,
Yeah,
Becca.
looking
Thanks.
forward to
See
having
you
you next
again
week.
soon.
Definitely take care, guys.
Welcome.
Yeah, welcome. Awesome. Well,
So,
oh, sorry. We are we're sponsored by Emily Griffith High School, and we're not the only ones representing our school. So we also have a student, Lily. So Lily, tell us the audience a little bit about yourself and how you help us here.
Hi guys, I'm Looney Lily, and I help get your questions in written form over to social media. I help get your questions to Nathan and Becca from social media, email, and text. And also at the top of each show, we have a trivia question. And the trivia question today is going to be on the first jack-o'-lanterns. If you're the first person to call in with the correct answer, you win a prize. And the question is, before pumpkins, what were used as the very first jack-o'-lanterns? And we will answer that at the end of the show.
All right, so if you have an answer or think you might have an answer, so a guess works as well, give us a call at that phone number at the top of your screen. But I'd also like to give you our other contact information because you can submit an answer that way or a question for your homework as well. So here's all the ways that you can contact us. Phone number top right of your screen, and Nathan gave that to you earlier. But you can also get a hold of us via social media at EG Homework on Facebook or Twitter. You can text us at 970-680-3771, or you can email us at homework@emilygriffith.edu. So those are all the different ways that you can get in contact with us. We're here until 5:30 to answer your questions live. So get a hold of us if that homework is giving you some trouble today. So in the meantime, let's go over to Lily and get some of our social media questions answered.
Okay.
What do you have for us?
So we have a logarithms question here, and it says 500 equals 7, parentheses, 2, end parentheses, to the second x power.
I am having a little bit of technical difficulties with my board. So, Nate, would you mind getting
I'm
this?
a little bit rusty, but I think I can
I can
probably
help you if.
get it all from you. So the question was, wait a minute. I think I'm having a little problem.
All right. Okay. Well, I can't really show you how to solve it. I'm sorry, but I will try to explain this as best as I can. So we have the equation is 500 equals 7 times 2 to the 2x power. So one of the things with this equation is that your exponent is actually the unknown. And so because the exponent is the unknown in this equation, we have to rewrite it into another form. And by rewriting it into the other form, so right now it's an exponential form. I don't know if, can't see it.
My
Sorry.
screen's actually working right now. If you want to hop over to me, I got it written
All
down
right,
here and set
so
up.
we're going to jump over to Nate.
So
Here's the equation.
So I got the equation written down here on my screen so we can see that. So again, we're trying to solve for x here, but one of the issues is the variable is in the exponent. So as Becca and Lily mentioned, this becomes a logarithmic problem. So to start off at first, well, we want to isolate the x. So first thing we want to do is just get rid of this 7. Or I don't want to say get rid of it, move it to the other side. So I have 500 over 7 equals 2 to the power of 2x. So, and Becca, you can correct me if I slip up here for a second. What we really want to do here is try to get this exponent out of, or the variable out of the exponent. So one way we can do this is we can do the logarithm of both of this side. And I didn't leave myself enough space actually, so I'm going to rewrite this. 500 over 7 equals 2 to the power of 2x. So again, one way that we can do this is we can do the logarithm of both sides. Oh, what happened there? So where is this? The logarithm of this side. And that's going to be, again, same thing as we always do with equations. If I do something to one side, I have to do it to the other. So it's going off my pen here. Now it's not working again.
Okay.
Oh, there it goes. All right, so I'm going to do the same thing to this side.
So this is definitely correct, and the only reason I'm stopping you is because there's a shorter way.
Oh, okay.
With this. So this is kind of what I was thinking. Run to my screen real quick. I'm sorry, Nate. I don't mean to cut you off here.
That's right. If you got a shorter way to do it, then that works too.
So if you have something that's written in exponential form on the left or on the top like that, you can rewrite it into logarithm form on the bottom.
That's what I forgot.
Rather than having to use all of the logarithm properties. And the only reason I say that is because the logarithm properties of simplifying are not necessarily something high schoolers have to learn.
Okay.
So they may not know those or may not be using those, if that makes sense. So the original problem, again, or you did the 500 divided by 7, is that right?
That's right.
And then equaled, and then it was 2 to the 2x power. Is that correct?
2 to the power of 2x, yeah.
Okay.
That's right.
All right, so we have it's written now in this exponential form like this. So we're going to rewrite it into logarithm form. The base is the 2, and so we're going to say log base 2. And then the a comes from the other side of the equal sign. So that's this 500 over 7. And then equals, and then what it equals is actually the power. So our power over here is 2x. So that's our power. So now we've rewritten it into logarithm form. Another formula that we have for logarithms is called the change of base formula, and that's just basically to put it from a base of 2 to a base of 10, or a base of 10, so that we can kind of find out what it equals. I kind of usually tell my students it's a calculator equation. So what we do is, so log base b of a, the way we'd rewrite something like that is log of a divided by log of b. So in the calculator, I'm actually going to type log of 500 divided by 7 over log of 2. And that's going to still equal 2x. And so that's something you're going to, pretty much for the most part, you'll need to use calculators for logarithms. So I'm going to go ahead and find out what that is. And you end up getting, and I'm approximating, about 6.1584 is equal to 2x. Now, the last thing that we need to do in order to finish solving this is isolate x. So there's just this little last step here of dividing by 2. So then our x is going to be approximately 3.0792. So kind of summing this up, any problem where you have a variable as your unknown, or sorry, an exponent as your unknown, where your variable is in the powers, that's where we're going to have to rewrite it in order to be able to isolate it. And so logarithms is the way that you rewrite exponential equations. And that's how it works out. So hopefully that helps. Thanks you for bearing with us with those technical difficulties. I apologize for that, but we got it working. We're good to go. So call us or let us know if that was not a good enough explanation for you.
Yeah, I actually worked it out on my screen. We don't need to look at it because it's kind of messy, but it got the same answer, but it was a lot more complicated and a lot messier. So that's the way I remembered how to do it, just off the top of my head. But
yeah, and you know what? It's nice to have multiple strategies to solve problems. You know?
And to be able to just think of whatever you remember about just all these different properties and apply them.
Absolutely. There's really no way to remember all of it anyway. So.
Right.
Yeah.
Probably one of the easiest things in Algebra 2, to be honest. Synthetic division is probably one of the most difficult in Algebra 2.
It's not
I will be
fun.
honest.
Yeah.
But yeah, it's easier than I expected.
And so I think we have time for one more social media question.
Okay.
All right, let's get that one.
This one says, a square has an area of 16. How long are each of its sides?
Okay, so it looks like Nate's.
Yeah, my pen's still not working, so.
It's like it traded. It just jumped from you to me to you to me. All right, so it was an area, it was a square with an area of 16. Okay, got this one. I can do this. I'm not geometry wonderful, but I think I can handle this one. So it's a square, and we know that it has an area of 16. Was it 16?
Area of 16.
Okay, it didn't really say what it was, but it's just 16. Okay. The one thing that we need to know about this is that squares, or properties of squares, is that all of the sides are equal. So we know that whatever one of the side lengths are, the other one is going to be the same. And so what we could possibly think of is when we make them variables or label the unknowns, we know it's going to be the same letter. Unlike a rectangle could be like x and y because they don't necessarily have the same side lengths. So square, we know area is length times width. So we know that x times x is going to give us area, which is 16. So then we just have to solve for x. So that also means x squared is going to give us 16. And, or we can think of what times itself equals 16. And so then therefore, it's going to be 4. The only other thing that could be multiplied by itself to give you 16 would be -4, but that wouldn't make sense in the context of this problem. And so we have to go with our positive answer. So our side lengths of our square are going to be 4. Hopefully that helps. That was a geometry question I could get.
That was. I appreciate you taking that one for me while I had
problem.
some technical difficulties over here.
All right. It's just a crazy, spooky episode.
It is. It makes sense for Halloween, right?
All right. We'll go.
All right. We actually have a
one
little
more
time for
social-
one more social media.
All right.
Okay.
Let's get some of those answered.
So he says that he just needs help setting it up, but he can take it from there. And it says, in a shop, the cost of 4 shirts, 4 pairs of trousers, and 2 hats is $560. Where do you shop? That's expensive. And then it
in
says,
a shop, the cost of, okay. I'm sorry, I'm just
Oh, no,
trying
it's
to write all
okay.
this down.
And then it says the cost of 9 shirts, 9 pairs of trousers, and 6 hats is $1,290. What is the total cost of 1 shirt, 1 pair of trousers, and 1 hat?
Is okay, is $560, and then 9 shirts.
9
my goodness.
trousers.
I'm going to say 9S for shirts. Okay, you can cut to my screen. I'm kind of setting this up right now. And that's actually sometimes some of the difficulty of word problems is setting them up and sifting through all of the words. So it's a, oh my goodness, 2 hats is 5, 9 shirts, 9 trousers,
And 6 hats.
is,
1,290.
and 1 shirt, 1 trouser, and 1 hat is going to be, we don't know. Okay. Well, actually, so this is a problem that has 3 variables, but doesn't have 3 equations. So I'm not really sure if there's enough information to set this up.
Yeah, you really need 3 different equations. Can we see that problem one more time? Make sure we're not
Yes.
missing anything. So I'm guessing what might be missing is the cost of an individual shirt, maybe? Or an
Yeah,
individual item?
yeah. So give us, if this is your question, could you please give us either a call back or just send us an email, because this is actually something that we can't answer unless we have a little bit more information. So let's give you our contact information. So this is actually to everybody. If you have homework questions and you missed the information from before, here's our contact information. The phone number's on the top right of your screen, 720-424-1666. You can also get a hold of us social media via Facebook and Twitter at EG Homework. You can text us at 970-680-3771, or you can email us your questions at homework@emilygriffith.edu. So those are all of the questions, or all of the ways that you can get a hold of us if you've got any homework questions, any homework issues. But let's go ahead and try, we're struggling today, but we're going to try to get another homework question answered from social media.
So he asked to factor 3x minus 12.
Is your computer working yet?
It is not working.
All right, I guess
I've got a plan,
I'll
but
get
nothing
this
on
one.
Just
then.
clowning
Sorry,
around over
Nathan.
here.
You're just hanging out. All right, so they wanted us to factor 3x minus 12. So the word factor basically means divide. So if we were, for example, if we were to factor the number 10, we would break it down to what multiplies to equal that, 2 times 5. So in order for you to factor an algebraic expression, what we want to look at is each of our terms separately. So this is a term, 3x, and negative 12 is a term. And what we want to think about is what is the greatest common factor, or the largest thing that can be divided out of both of these terms. And 3x and negative 12, what they have in common is a 3. So we're going to divide them both by 3. So when we divide 3x by 3, so 3x divided by 3, it's going to give you just x. So 3, and then we're going to be just left with x. Then when we take negative 12, we divide it by 3, we're just left with negative 4. So this is kind of like factoring is backwards from distributing, if you remember what distributing is. So you could always check your answer by multiplying it back together or distributing, just to double check you still get the thing that you originally started with. So 3 times x is 3x, 3 times negative 4, negative 12, and yes, in fact, we do get what we started with. So 3 times x minus 4, that is the factored form of the expression 3x minus 12. So hopefully that helps. That was a little bit more straightforward of a question. Thank you for that.
It looks like
All
my
right.
pen is finally working again.
Oh,
so
hey.
I can actually answer some
All
questions
right, can
here.
finally do some work around here, okay?
Yeah.
All right.
Maybe I shouldn't have said anything.
Okay, well, actually, we're going to talk about some math shortcuts
Oh, that's good
that,
timing.
that
then.
you have. So it's
Now
perfect
working.
timing. So you take over from here.
So really quickly, I was actually just curious if you remember the shortcut we went over yesterday.
Oh, it was the numbers squared.
Yeah, so do you know what 85 squared is?
It is 7,225.
Yeah, see, so
Woohoo, I'm a
again,
math
like
genius.
it was really easy to remember. If you guys want to review that really quick, all it was like if I have 85 squared, all we did yesterday was say what comes after 8. So 9 comes after 8, so 8 times 9 is 72, and then we just throw a 25 at the end. A really quick, easy, that's right. Quick, easy trick to remember. One that I want to talk about today is actually a little bit more challenging, but once you get the hang of it, it comes pretty quickly. I actually use this quite a bit in my class, just when I'm up at the board doing some work really quick. So if you have any 2-digit number up to 19, multiply by another 2-digit number up to 19, there's also a kind of another quick way. It's a little bit more challenging to do in your head, but with a little bit of practice, it's not too bad. So if you give me two numbers up to 19.
Let's see, let's go 11 and 17.
11 and 17 is 187.
Oh, wow.
So
Okay, how
all
did
I
you do
did there is, again, let's see, 11 times 17 is what you said, and I'm actually going to write it like this, a little easier to see what's happening here. And all I'm doing is I'm taking this 2-digit number on top, and I'm adding it to this 7, which is going to be 18. And then I throw a 0 in there, so I have 180. And then all I'm going to do is take these numbers, 1 and 7. 1 times 7 is 7. And then I just add that here, and I get 187. So this works with any 2-digit numbers up to 19. So if I did like
Okay, let's try another one. So
18.
18 times 16.
16, so I'll do 240, 48, it's 288.
So you did 18 plus 6, which
18
is
plus
24. And then you added
Oh,
a
I
0
messed
at
that
the
one up.
end.
So it's actually, oh, I said 288. Okay.
And then you added the 8 plus the 6.
8
Which-
times the 6.
Oh, 8
So I'm
times
looking
the
in here.
6, which is 48. And so you
48.
took 240 plus 48.
And then 288.
Oh, do you know why that works?
I have no idea. I think it has something to do with like the place values of where they're at. So
Okay.
like 8 times 6 is going to come at the end. So you're definitely going to have to multiply those and add them.
Okay.
But we're still getting the 18.
Oh, maybe it has to
I'm
do
sure
with
that
the tens.
I think it does.
You know,
with
by
the
multiplying by
placing.
10,
Yeah.
something like that.
So it only works on 2-digit numbers from like 11 to 19.
Okay, that is really interesting.
Yeah, so it takes a little bit more practice. You can see it's a little bit more involved than what we did yesterday, but
still,
yeah, and
yeah,
it's helpful.
nice-
Like you don't have to pull out your calculator so
if
much.
you don't have a
and,
calculator, you could
Yeah.
definitely do that a lot easier.
Yeah.
Very cool. All right.
All right.
Do you have any other shortcuts?
So there are some actually. If you, this isn't like a shortcut, but if I did like 20, let's say 23 times 19, you might have a way of doing this where
Okay.
what I do is think of something that you can multiply easily, like maybe 23 times 20, which would be 460. And then this 19 means that we're 1 short on the 23, right?
Right.
So we can subtract 23 from that, and we get 437.
Yeah. Oh,
So-
yes, exactly. So, like,
Yeah.
another one would be, for example, like 18 times 21.
Yeah, so I would
You
do
18 times
360
20.
plus 18, 378.
Right, exactly.
So-
rounding, doing easier math by using like rounding to the nearest tens or
Yeah.
hundreds or something like that, and adjusting from there.
Yeah, so you don't always have to
Mm-hmm.
do like the kind of longer way method of like setting up, or I think there's another method, like the kind of a box method. for multiplying.
Oh, right. Yes, there is. Yeah.
Yeah, but you can always kind of manipulate the numbers to make it a little easier for yourself. So like we said, 18 times 20 is 360. And then what you're seeing here is that I have one more 18.
18.
So we just add that other 18 and you get 378.
Yeah. That's
So-
how I do it in my head. That is a good mental
Yeah.
math trick for sure.
So again, like it's not so much a trick as like the other ones. I don't really know how they work out mathematically.
Right.
But it's just a way of like using number sense to kind of do it in your head rather than a calculator or
Makes a lot of
long term.
sense. Yeah. Makes a lot of sense. Cool.
Sounds like we have a caller actually, so good timing on that.
Okay. We have a caller. Awesome. So can you hear us? Hello. Are you there?
Hello, is this the Homework Help Hotline?
Hi.
It is. Hi.
Yes.
Hi, I'm calling because I have this question from my math class that I'm having a hard time with.
Okay.
All right.
I think it's what's called a polynomial, and I think that I need to factor, but I'm having a hard time because it includes an x cubed.
Okay.
And I'm not quite sure how to work with that.
Oh, I can help you with that. That's
Okay,
what we're working on in class right now. So
Oh,
what is the
nice.
polynomial that you have?
Yeah, so it's x cubed
Okay.
plus 5x squared
Okay.
plus 2x minus 8
Okay.
equals 0.
Okay.
And I'm supposed to solve for x.
Okay. So you were right when you said you will need to factor it to be able to solve it. So and you're also right in that if it's a cubed, it's a lot harder to factor than just a regular quadratic. So have you in class done anything with rational root theorem or synthetic division?
I'm not sure.
Okay, so let me know if this sounds familiar. So in order to possibly find one of the possible things that we can factor it, let me kind of give you an example with whole numbers really quick. Let's say I had, I don't know, this number 256, and we were told, all right, we have to factor it, meaning we have to break it down. We might not be as familiar with the times tables of larger numbers, and so the way that we might figure out a factor is by testing through division. And so we're looking for something whenever we're testing through division, something that doesn't have a remainder. So a remainder of 0. For example, if we thought maybe 2 was a factor of 256, we would divide 256, divide it by 2, and see if there was a remainder or not. Does that make sense?
It does.
Okay, so we're going to be doing the same thing with polynomials, except for we don't have the same kinds of clues like we do with whole numbers. Like for example, 256, we knew, oh, that's even, so we can divide it by 2 probably. The way that we get our clues for polynomials is what's called the rational root theorem. And to do that, we're going to look at our last term, so the constant, and the leading coefficient, so the number in the front, in the very beginning. And we're going to set it up as P over Q. P just stands for all of the factors of this constant, and Q stands for all the factors of this leading coefficient. So factors of 8, what would be factors of 8? Do you know?
Okay, maybe like a 1, a 2, a 4, and an 8?
You got it. Awesome. And so that'll be those are the things that we can put on our numerator. And then denominator is coming from factors of this 1, this leading coefficient. So what would be factors of that?
Is that just 1?
Yep, just 1, exactly. So now what we're going to do is just make combinations. So we'll do 1 over 1, so just that top number over the bottom number, which just equals 1,
Okay.
right? And we're going to test maybe the positive and the negative of that. We're going to do the same with the 2, the 4, and the 8. So that's going to give us positive negative 2, positive negative 4, positive negative 8. So here's our list of basically the things that we can test with the division to see if it's going to give us a remainder or not. You can do, whenever you test these numbers, you can use either long division or synthetic division. Either one works. I prefer synthetic division because it's a little bit less complicated, but it does the same thing. So we might start with we'll start with positive 1. So the way we set this up is we put the 1 in the box. So these are all the numbers that we're testing. So these are the things we're testing. And then we write the coefficients next to that. So 1, 5, 2, and -8. So all of these coefficients here, the numbers in front of x. And then from there, the process is kind of cool because it's not actually division. We're going to just bring down a number, the first number, and then we multiply. So 1 times this 1, which is just 1. And then we're going to add the 5 and the 1 together, so 6. We're going to continue that process. So 6 times the 1, 6, and then we're going to add these two numbers together. So 2 plus 6, 8. 8 times the 1, 8, and add these two numbers, 0. You know how we were talking about that remainder?
Right.
What were we looking at for, what did we want to be our remainder?
We wanted it to be 0.
Yes, exactly. So that means it goes into it evenly. So that last number there, that -8 plus 8, that's our remainder. That means it goes into it evenly.
So does this mean I don't have to test any other numbers? We found it?
Yep, it means we found it.
Nice.
So the way that we're going to write that is actually, so this 1 works. That means it's a root. The way we write it in a factor is we say x minus whatever our root is, which is 1.
Okay.
And then this stuff on the bottom, and I'm going to highlight it here, this is the other thing that multiplies to equal that. So basically, you know how if we were to factor 10, we would do 10 divided by 2 is 5. That gives us a clue that we could rewrite 10 as 2 times 5. So we're going to do the same thing here, is this polynomial, this big long one, divided by the x minus 1 is equal to what I highlighted. So what I highlighted times the x minus 1 is going to equal the polynomial that we have at the top. So these numbers here are all of the coefficients of our answer. So the 8 is the constant, the 6 is the coefficient in front of x, and the 1 is the coefficient in front of x squared.
Gotcha.
So would look like that. So then from here, we still have to factor that x squared, and that you might be familiar with already, but that ends up factoring into x plus 2, x plus 4.
Right.
And then from there, since it's factored, we can just set each factor equal to 0 and solve for them. So what would this first x give us?
So it looks like +1?
Exactly. So one of our answers is x is 1. And then what would the second one give us?
-2?
Good, exactly. So that would be our second answer. And then our last one would be?
-4.
You got it. So by using this synthetic division to help us factor, you can break it down to all the smallest factors and then therefore solve it. So did that help?
Yeah, that helped a lot. That made a
Okay.
lot of sense. Thank you.
Good. I'm glad. Call us back if you have any more questions. Thank you so much.
Okay, I definitely will. Take care.
All right, you too.
I really feel like you're doing all the work today.
I know. Whew. Let's get you some work.
Yeah, let's see if we can find anything.
I think I have a geometry question for
Oh,
you.
right.
yes.
It says, in a quadrilateral, 2 angles are equal. The third angle is equal to the sum of the 2 equal angles. The fourth angle is 60 degrees less than twice the sum of the other 3 angles. Find the measures of the angles in the quadrilateral. Ugh, that's a tongue twister.
Whew.
All right. So
We had to get you some work, you know?
I think so. I shouldn't have commented. So on my screen, I just drew a quick quadrilateral. I think this might be another systems equation when I'm looking at it. So
Kids just love these systems.
Yeah, I think everybody seems to.
Oh, they're tricky. That's probably
Yeah.
why people
Yeah.
have questions on them.
That's true. So I drew a quadrilateral. This isn't going to be to scale. But first of all, I'm going to just label everything. When I look at this problem again, I even think it looks pretty complicated. But I think just going through and labeling everything is going to help. So I'm trying to find all the angles in the quadrilateral. So I'm just going to label them. So first I'm going to have an angle, and I have 2 angles that are equal. So if I call this angle x, then I can also call this angle x. It says the third angle is equal to the sum of the two equal angles. So I'm going to call this my third angle. Well, we know this angle is equal to the sum of my two equal angles, so those two angles added up. The fourth angle is 60 degrees less than twice the sum of the other three angles. So fourth angle, I probably need a little bit of space here. I'm going to say my fourth angle is 60 degrees less. So again, messy, but I'm just going to go through this piece by piece. 60 degrees less, so we're saying we're going to subtract. Then twice the sum, so I might still run out of room, twice the sum of the other three angles. So one of my angles was x, another one was x, and the other one was x plus x. Right. I'm going to erase this and kind of clean this up a little bit. Oh, no, that's a little bit too much. So I'm going to put that minus 60 back over here. So I'm going to again read through this problem and make sure that I got everything set up correctly. Again, these more complicated problems, I'm looking at this now and it's not a systems equation. But when I look at this, I want to make sure that all this work I just did actually fits in the problem, so I'm not solving this kind of mess of a problem and then realizing I set it up incorrectly. So I'm going to walk through it again. I said two angles are equal. So I got my two equal angles, x and x. Got them here and here. So that works. Then I have a third angle that's equal to the sum of the two angles. So that's the sum of the two. And the fourth angle, the tricky one, was 60 degrees less than twice the sum, so twice the sum of all the other angles combined. So all I did was add them up. And I have x plus x plus x plus x. So from there, actually, this becomes not too difficult to solve. You also need to know properties of a quadrilateral. When I look at a quadrilateral, I know that all the angles have to add up to 360 degrees. So actually, it's going to be a little messy, but a lot of this is going to come down to just being careful and simplifying. So I'm saying all the angles, so my first two angles, x plus x, plus, I'm going to put these in parentheses to make it a little more clear that these are my first two identical angles, plus my third angle, x plus x, plus my fourth angle, I'm putting everything in parentheses or in brackets, 2 times x plus x plus x plus x. Make sure I got enough parentheses here, minus 60. And we know the sum of all the angles in the quadrilateral have to equal 360. So I'm setting all of this equal to 360. So that's why I said this really becomes just an exercise in being careful with your work and also simplifying a lot. So I'm going to go through this piece by piece, kind of using, I'm going to add all these up. X plus x plus x plus x is going to be 4x. And that's all of this right here. Then this is a little bit more to work with. I'm going to keep this in parentheses. 2 times another 4x minus 60 and still equals 360. So all I'm really trying to do here is simplify and kind of whittle this down into a problem that's, again, more manageable. So I'm continuing to simplify. So I'm using PEMDAS. So the first thing I want to do is simplify everything in the parentheses. So I have 4x plus, and inside the parentheses, 2 times 4x is 8x minus 60. Still leaving my 360 alone. I haven't done anything to this side yet. And continue to simplify. Where's my marker? 4x, I'm actually just going to do this really quick. 4x plus 8x is 12x. And then minus 60 equals 360 degrees. So all I'm going to do now is add 60 to both sides. And 12x equals 420. All right. So now I need to quickly just divide 420. So I'm going to divide 12 from both sides. And I'm going to get x equals 35. Okay. So I haven't actually answered the problem yet, because if you look back at the problem, and I think this is an important step in that I've seen a lot of students just stop here at x equals 35 and be like, I figured out what x is. But if you look back at the problem said to find the measures of all the angles in the quadrilateral. So I'm going to kind of go back to the top here and remember that I've done all this work, and now I figured out that x equals 35. So I'm actually going to quickly draw another quadrilateral so I have some space here. Well, I know that this angle has to be 35 because it's x, 35 degrees. This angle has to be 35 degrees. And then this angle is the sum of the two identical angles. So 35 plus 35, which is 70 degrees. And now I have two options here. I can either kind of go back here and plug all of this. I can plug 35 back into all of this equation and figure it out. Or I can just remember what I talked about with quadrilaterals, and that they should all add up to 360 degrees. So I know that I have a 35 degree angle, another 35 degree angle, a 70 degree angle, and I need to know, I'm just going to call this a different variable, call it y. All has to add up to 360. This is getting a little messy. I'm just going to go ahead and simplify. 35 plus 35 plus 70 is going to be 140, plus that other angle that I'm looking for is going to equal 360. And then we're just solving by subtracting 140 on both sides. So y is going to equal 240 degrees. So my last angle is
220.
Oh, 220? Oh, sorry. Yeah, 220.
That's okay.
220 degrees. So scratch out this over here, and that should have been 220. Thanks for catching that.
Yeah.
So that would solve my problem. Again, it's a lot to work with, and when you first read this problem, it seems a little intimidating. But just go through. Drawing a figure always helps. And just, start with what you know, start with what's easy, and just try to plug everything into the quadrilateral and think about what you can do from there.
A lot of times those word problems are very difficult, and the way that you sifted through that and just took it one little part at a time, that's exactly how I try to direct my students to solve them too, because this is difficult.
Just one sentence at a time.
Yeah,
Don't overwhelm
very
yourself.
true. One piece at a time is not too hard. All right, so we're going to go to the commercial, check out some information about Emily Griffith High School, and then also another show that we have on our network, so check it out.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
All right, hopefully you learned a little bit more about Emily Griffith. We're going to go ahead and hop over to Lily, who's going to share our Facebook discussion.
So today we're going to be talking about the corpse flower, which is actually one of the most rarest flowers in the world, and Denver seems to be the home of it. And what's interesting about this flower is that it's supposed to smell like a rotting corpse when it's bloomed. So it's kind of gross, but it's kind of cool at the same time. So
I
Yeah.
gotta be honest, I'm kind of glad it's a rare flower and it's not just like blooming in my yard.
Everywhere.
oh no.
So it's actually nicknamed Stinky, I heard. And it's been described as, like the smell has been described as a number of dead mice, maybe rotting in an abandoned locker room.
Oh.
So that sounds
Oh,
quite
that's pretty gross.
I don't think I've ever smelled that before, but I wouldn't want to.
I feel like I've smelled
yeah.
both separately, but together. that
Maybe
might
the
be
old
a
Emily
little bit
Griffith High
much.
School.
Yeah.
Terrible, terrible. So after it blooms, what happens is in the course of like 72 hours or so, it releases this scent and the purpose of it is, there actually is a purpose to it. And the reason is that it's trying to attract bugs so that the bugs will pollinate it. And so these bugs are attracted to this corpse smell, basically. And then what happens is once it gets pollinated by the bugs, the flower dies, and then the plant actually goes dormant for another half dozen years. So it doesn't bloom very often at all. It blooms again in another half dozen years. So yeah, this actually was in Denver relatively recently.
I think it was in August it was blooming, actually.
Yeah, I was gonna say it was at the end of the summer, I think, is when I heard about it. So
I don't know if I'm sad that I missed it, or maybe I should have gone.
I thought about going, but then I
don't
thought, I don't know.
Did a lot of people go see it? Or?
I heard that at the Denver Botanical Gardens that over 35,000 people went to go see it or smell it, I guess. So yeah, over just a 10-day period. So
wow.
I find that really crazy, in my opinion.
I imagine that's a lot higher volume than we're used to.
They probably made a lot of money that day. So
That's true. That's true.
Wow.
So, oh, it sounds like we have a caller.
All right.
So let's get our caller. Hello.
Hello, you there?
Hello.
Hi, I got a math problem that I need some assistance with.
Okay.
All right. That's what we're here for.
Yeah.
The problem is, what is the equation of a circle with its center at 0, 0 that passes through the point 3, 4 in the standard coordinate plane?
Okay, looks like another geometry question, so I can take that one.
Sounds tricky.
So the center of the circle is at 0, 0.
Correct.
And it passes through the point 3, 4, right?
Correct.
Can you see this on my screen? Are you watching now?
Yes, I am.
All right, so I'm going to do a couple things. I think it's helpful to kind of see what this looks like. So I'm going to go ahead and pull up a graph so I can draw a circle on it. So I got a graph up here. Now, the thing with this problem is you really need to know the equation. Sorry, I'm having a little trouble moving this. The equation of a circle. So I'm going to go ahead and write that on my screen before we get started. And when you're looking for like the equation of a circle or a quadratic equation, and you have some information, I think one of the best things you can do is actually just write down the equation first before you do anything else. And then you can start to think about like what you know and what you need to know. All right?
Sounds good.
So I'm going to go ahead and write this down on my screen. Oh, fix that real quick. Need a parentheses there. So does this equation look familiar?
Yes, it does.
Okay, so let's really quick think about what each piece of this is. So when I look at this, you have the circle center. I'm going to go ahead and highlight some of these variables, like h, k, and r. So in this equation, if you remember, the h and the k are going to represent, so I'm going to say hk. This is going to represent the center of the circle. Does that sound familiar?
Yes, it does.
Okay, so I'm going to go ahead and draw a circle over here. Clean that up a little bit. Oh. So I'm going to have a center right here at the origin at 0, 0, right?
All right.
Now I'm going to do my best to draw a circle here, but I got to be honest, it's probably not going to be the best circle. But we're passing through the point here, 3, 4. So it's going to look something like, that kind of looks like a circle, right?
Yes, it does.
All right. You got the general idea. It's circle-ish. All right. So when we're saying, I'm going to go ahead and start plugging in what I know here. This point was 3, 4. So we said the center was HK. So I'm just going to go ahead and plug in everything I know here. So x minus the h, which is going to be 0, because that's my x coordinate of the center, and then that's squared, plus the y minus 0 squared, and then that equals r squared. Is this looking a little familiar to you?
Yes, it does.
Oh, sorry, there should be a plus in the middle there.
Oh, I see.
Fix that. Okay, so one of the things with this is actually, I have most of this resolved. I'm going to simplify this really quick, actually. So x minus 0 squared is going to be x squared plus y squared equals r squared. Now, when we're looking for the equation here, what we actually need to know, the only other piece we need is the radius. So I'm going to take a look at this really quick, and what we're looking for is the distance from the center to really any point on the outside of this circle. So the information you gave me was that it passes through the point 3, 4. So we're going to use that. So am I just drawing all over the place? So what we can do is actually, to find this distance, we can kind of set this up like a triangle. You see what I'm doing here?
Yes, I do.
Okay. So I'm going to try to make it a little darker so you can see it on the TV. And what I have here is actually, I've drawn a right triangle. So if you look here, if the x-coordinate is 3, do you know how many spaces over we moved on the bottom of the triangle?
We moved 4, I believe.
I'm sorry? I think you cut out for a second.
We moved 3.
Okay, we moved 3. So remember, this is the x-coordinate, or the x-axis, and this is the y-axis up here. So what we're saying is if our x-coordinate is 3, we've moved over 3 spaces. And then how many up have we moved?
4.
4. So now we have some pieces of a right triangle that you can solve. Again, we're looking for this distance. Do you remember what the radius here would be called if I'm looking at a right triangle?
Wouldn't that be the hypotenuse?
That would be the hypotenuse. So that's actually what we're looking for. The radius is going to be the hypotenuse of the right triangle that we just came up with. So we're going to use a little Pythagorean theorem here. 3 squared plus 4 squared equals, and I'm going to use r squared. And from here, we just go ahead and simplify. 3 squared is 9 plus 4 squared, which is 16, equals r squared. And we're just solving this equation for r now. So 9 plus 6 is 25, and that's going to equal r squared. And then to solve, to isolate the r, we need to do the square root of both sides. So we're going to get r equals 5. And interestingly, whenever we do this mathematically, you could say that r is going to be plus or minus 5. But do you think we can have a negative radius of a circle?
No, I don't.
No, so that kind of cuts out one of our possible answers here. And so our radius is just going to equal 5. So we have all the information we need now, and we're just going to plug this back into the equation. And we have, what is in a different color, this is a little more clear. Coming back over here, I have x squared plus y squared. This part's done. That's going to equal 5 squared. And we can actually write this in this form, a little simplified. X squared plus y squared equals 25. That would be the equation of your circle. Does that help?
Yes, that definitely did. Thank you so much.
All right, great. Thanks for calling.
Very nice. We're going to go over to Lily, and we're going to get our trivia. Oh, actually, let's repeat the trivia question just to make sure that everybody knows what trivia question we are answering today. And just a reminder, our question was, it's Halloween themed, of course, before pumpkins, what were used as the first jack-o'-lanterns? So we didn't. You've got about 3 seconds to call in if you could do it really fast.
So hopefully you got us on speed dial. You can just
And
jump
it's
in there
over,
really quick.
so.
Oh, time is up.
3, 2, 1.
We'll go over to
Time up. All right, Lily, tell us what our answer
So
is.
the answer was actually turnips, potatoes, and beets.
Oh.
Oh, wow. I
Very
actually didn't know anything was used for carving jack-o'-lanterns before.
Jack-o'-lanterns. So what do you know about jack-o'-lanterns, Lily?
Well, people actually have been making them for centuries, and it actually came from an old Irish myth about a man named Stingy Jack. And what the story is that Stingy Jack invited the devil to have a drink with him, but obviously, to his name, he didn't want to pay for the drinks, and so he convinced the devil to make him into a coin, so then he could be basically used to pay for their drinks. So.
Oh. Yeah. So, but instead of pumpkins, they were using potatoes and turnips.
Yeah, going back to Stingy Jack. Soon after he died in Ireland and Scotland, people began to make their own versions of jack-o'-lanterns. And that was actually by carving scary faces into turnips or potatoes and placing them into their windows or near doors to frighten away Stingy Jack and other wandering evil spirits.
Mm. So in England, they were using these large beets. And then immigrants from these countries brought this tradition. They brought this from Europe. They brought this tradition with them when they came to the United States. But then they discovered that pumpkins were actually perfect to make the jack-o'-lanterns. I mean, think about whenever you have a pumpkin, you can just kind of clear it out and get all of the inside out really easily and hollow it out, whereas I think beets wouldn't be as easy to hollow out.
They're a little bit more solid.
Yeah, exactly. So they found out they were perfect. So that's when they immigrated to America, they started using pumpkins.
Are you guys carving anything this year?
I don't mess with
I've never really carved pumpkins before.
You never have?
No, my family's Mexican American, so we don't really celebrate Halloween that much. We just celebrate Day of the Dead, Dia de los Muertos, if there's any Spanish viewers out there. But yeah, so we don't really celebrate Halloween that much. My parents are really Catholic, so they're kind of iffy about Halloween, so we've never really carved pumpkins. I didn't really carve pumpkins till I was like 16 years old. So. Yeah. So.
What did you carve when you were 16?
When I did carve a pumpkin, I tried to carve Beetlejuice, and it did not turn out like Beetlejuice at all. It just turned out like a man with, it just turned out awful. It didn't even look like a man. It just looked like a blob of nothing. His hair was like spaghetti noodles. It was awful.
I tried to do too.
I carved a stormtrooper a couple years ago.
Oh, wow. Awesome.
It kind of, I think it looked like a stormtrooper. I would argue that. Actually, I think
fancy.
As it started to age and kind of sag in, it looked more like a stormtrooper, which I guess is what I was going for.
There you go. Now you just need to carve it earlier.
Yeah.
So what are you going as Halloween this year?
I don't know. I already got this awesome clown wig, so I might just continue with that.
Yeah, I'm going to keep doing my little she-devil thing, maybe. I don't know. How about you, Lily?
I'm a witch. I've been a witch every year, pretty much. Except I was going to change it up this year and be Athena, but I don't really have a white dress, so I was just going to be a witch instead.
Got to stay with the evil theme.
Yes, indeed.
Yeah, got to stay scary. I love giving out candy, though, for Halloween. I don't love dressing up myself or trick-or-treating myself or carving pumpkins myself, but I love giving out candy because I love seeing all of the little kids come to my doors with all of the cute costumes. So, all right, so for Halloween weekend this year, please be safe. Please listen to your parents and your family and have a lot of fun. If you want to check us out on YouTube and Facebook, please do that. Also put in your social media questions for next week. We'll be back on Tuesday and Wednesday from 4:30 to 5:30. See you then. Bye. Happy Halloween.